In another remarkable achievement, SpaceX marked its 300th successful mission by launching 23 Starlink satellites into orbit. The momentous event unfolded as a Falcon 9 rocket gracefully ascended from Cape Canaveral Space Force Station on Sunday at 8:52 p.m. Eastern Standard Time. SpaceX took to social media platform X to share the success, highlighting the flawless execution of the mission. A notable aspect of this achievement was the Falcon 9's first stage making a triumphant return to Earth, landing precisely on the drone ship named a Shortfall of Gravitas stationed in the Atlantic Ocean. Impressively, this marked the 12th launch and landing for this particular booster, having previously completed 7 other Starlink missions. Continuing its journey, the Falcon 9's upper stage diligently transported the 23 Starlink satellites to low Earth orbit, deploying them approximately 64.5 minutes after liftoff. This launch was the second installment of a Starlink doubleheader, as an earlier Falcon 9 mission from California's Vandenberg Space Force Base also delivered a batch of Starlink satellites on the same day. Starlink, SpaceX's expansive broadband megaconstellation, currently boasts more than 5,250 operational spacecraft. However, this number is continuously growing, exemplified by the success of the 2 liftoffs on Sunday. The deployment of these satellites contributes to the expansion and enhancement of global internet coverage, showcasing SpaceX's ongoing commitment to revolutionizing communication and connectivity on a global scale. In a cosmic feat, the James Webb Space Telescope, JWST, has unearthed the most ancient and remote black hole ever detected. This voracious celestial entity, born a mere 400 million years after the resounding Big Bang, is currently devouring its host galaxy in a cosmic banquet. This groundbreaking discovery might hold the key to unraveling the mystery of how supermassive black holes achieved staggering sizes, equivalent to millions of billions of solar masses in the universe's infancy. Nestled within the ancient galaxy GN-Z11, located a mind-boggling 13.4 billion light-years away, this black hole provides a glimpse into cosmic history, capturing its image just 400 million years post-Big Bang. With a mass roughly 6 million times that of our Sun, it's exhibiting a feeding frenzy, surpassing the limits proposed by current theories. The formation of such colossal black holes during the universe's first billion years challenges existing theories. Scientists contemplate 2 primary pathways to supermassive status: the gradual growth from small black hole seeds originating from the collapse of massive stars over millions or billions of years, or a shortcut where immense clouds of cold gas and dust rapidly collapse into heavy black hole seeds, with a mass several million times that of the Sun. The unveiling of this ancient black hole, with a mass in the ballpark of a few million times that of our Sun, lends credence to the heavy seed theory, supporting the notion that these massive entities could skip the lengthy stellar evolution process. However, the accelerated rate at which the GN-Z11 black hole is consuming matter introduces a twist, suggesting that black holes might possess the ability to feed at a pace faster than their early universe counterparts. This challenges previous observations and provides a boost to the theories proposing the existence of small black hole seeds. In a climate milestone, NASA's analysis reveals that 2023 clinched the title of Earth's warmest year on record. The agency's Goddard Institute for Space Studies in New York disclosed that global temperatures soared approximately 1.2 degrees Celsius above NASA's baseline period, 1951 to 1980, average. This record-setting warmth triggered extreme heat for millions worldwide, with each month from June to December establishing a global record for its respective time frame. Notably, July emerged as the hottest month ever recorded. The overarching picture for 2023 depicts Earth as around 1.4 degrees Celsius warmer than the late 19th century average, marking it as the warmest year since modern record-keeping commenced in 1880. Remarkably, the past decade has seen each year consecutively ranking as the warmest on record. Curiously, how does a space agency like NASA delve into monitoring Earth's ground temperature? Despite being renowned for space exploration, NASA investigates our planet's climate by examining long-term warming trends attributed to human activities. In addition to human-induced factors, scientists explore natural phenomena such as El Niño, aerosols, pollution, and volcanic eruptions that can influence short-term climate variations. El Niño, a climatic oscillation in the Pacific Ocean, typically dominates year-to-year temperature fluctuations. The ocean pattern, alternating between El Niño and La Niña phases, impacts global temperatures. From 2020 to 2022, 3 consecutive La Niña events cooled temperatures. However, May 2023 marked a transition from La Niña to El Niño, a phase associated with record-breaking heat. Surprisingly, the peak of the El Niño event is anticipated to impact temperatures in February, March, and April, yet the second half of 2023 already experienced record highs. This underscores the complex interplay of factors influencing Earth's climate, prompting scientists to scrutinize various contributors to understand the dynamics of our warming planet. SpaceX successfully launched Axiom Space's third private astronaut mission on January 18, transporting a seasoned former NASA astronaut and 3 astronauts from European countries to the International Space Station, ISS. Originally scheduled for January 17, the launch was postponed less than 6 hours before liftoff as SpaceX needed an extra day for pre-launch checkouts and data analysis on the vehicle. The spacecraft is set to dock with the ISS on January 20, staying connected for about 2 weeks before returning to Earth with its 4-person crew. Axiom Space is organizing these missions, including Ax-3, to gather valuable experience in spaceflight operations. The company is gearing up to install commercial modules on the ISS, forming the foundation of an independent commercial space station once the ISS is retired. Ax-3 is under the command of former NASA astronaut Michael Lopez Alegria, marking his 6th spaceflight. Lopez Alegria, who commanded Ax-1 as well, previously participated in 3 shuttle missions and a long-duration ISS mission during his tenure with NASA. The remaining 3 members of the crew represent European nations. Italian Air Force officer Walter Villadei, the Ax-3 pilot, served as the backup pilot for Ax-2, and participated in Virgin Galactic's inaugural commercial flight of its Versus Unity suborbital spaceplane in June 2023. The mission specialists are Alpa Cezarab from Turkey, a pilot in the Turkish Air Force and the first person from the country to venture into space, and Marcus Wann from Sweden, a former Swedish Air Force pilot and the second Swede to travel to space. NASA is actively supporting private astronaut missions, as part of its broader strategy to encourage the development of commercial space stations, which are intended to succeed the ISS upon its retirement by the end of the decade. In 2020, NASA awarded a contract to Axiom, granting it access to a docking port on the ISS for its commercial modules. Additionally, the space agency has provided funding through Space Act agreements to support the station concepts of Blue Origin and Voyager Space. Astroscale, in collaboration with the U.S. Space Force, has unveiled its operational concept for an innovative in-orbit refueling vehicle. This spacecraft, developed in partnership with Orbit Fab, aims to capture propellant from a fuel depot and transport it to Astroscale's Lexi satellite servicing vehicle. Unlike conventional methods where the client satellite maneuvers to a fuel depot, Astroscale's refueling vehicle will traverse between a geostationary Earth orbit fuel station and the client satellite, facilitating uninterrupted client operations. Based in Japan with a U.S. subsidiary in Colorado, Astroscale specializes in space services geared towards extending the lifespan of satellites. Last year, the company secured a $25.5 million contract from the U.S. Space Force to pioneer the development of this groundbreaking refueling vehicle. In a unique private-public partnership, Astroscale and its collaborators will inject an additional $12 million in funding into the project, named APSR, Astroscale Prototype Servicer for Refueling. The vehicle is designed to be a compact satellite, comparable in size to a gas pump. Engineered for multiple refueling missions in geostationary Earth orbit, GEO, APSR will rendezvous and dock with a fuel depot operated by Orbit Fab. This innovative startup focuses on establishing space-based refueling stations, and is currently working on a hydrazine fueling station positioned 36,000 kilometers above Earth. The Pentagon's Defense Innovation Unit has contributed $13.3 million to support Orbit Fab's efforts. The recipient of the refueled propellant will be Astroscale's Life Extension in-orbit, Lexi, satellite, tailored for performing life extension services in geostationary orbit. Astroscale had previously announced plans to launch Lexi in 2026, and had inked an agreement with Orbit Fab for refueling services. Astroscale's recent announcement outlines the ambitious goal of delivering the APSR by 2026, marking a significant stride in the development of advanced in-orbit refueling capabilities. Japan's Moon Sniper mission made a triumphant touchdown on the lunar surface on January 19, marking a significant achievement as Japan becomes the fifth nation to softly land on Earth's nearest celestial neighbor. The exclusive moon landing club previously included the Soviet Union and the United States, who first landed during the Cold War space race, followed by China in December 2013 and India in August with its Chandrayaan-3 lander rover duo. However, the success of the SLIM probe was accompanied by a setback. Its solar panels are not generating electricity as originally planned, according to officials from the Japan Aerospace Exploration Agency. This hiccup could jeopardize the mission. As SLIM's battery can only sustain operations on the Moon for a few hours, the SLIM probe, which stands for Smart Lander for Investigating Moon, embarked on its journey last September alongside the XRISM X-ray Space Telescope. While XRISM successfully deployed into low Earth orbit and transmitted its first test images, SLIM continued its ambitious mission to the Moon. Despite initial success in hitting milestones during the descent and maintaining communication with ground control, SLIM encountered a puzzling issue post-landing. Its solar panels were failing to generate power on the lunar surface. JAXA officials could not immediately determine the cause, suggesting that the solar cells might not be oriented towards the Sun as expected. While SLIM represents Japan's latest lunar endeavor, it's not the first attempt. Previously, the nation had sent the Omotenashi lander on NASA's Artemis 1 mission in late 2022, but communication was lost, leading to an abandoned landing attempt. In April 2023, the private Hakuto R lander, operated by Tokyo-based company ISPIS, reached lunar orbit but unfortunately crashed during its touchdown attempt due to confusion caused by the rim of a lunar crater.